So this is day 2 or video 2 of notes number 5 for the parabolas. Basically in this video, I'm going to hit certain questions on page 2, the ones that are not like what was on page 1. And basically that would be like number 6. So problem number 6, we've got a parabola with zeros at x is equal to 1 and x is equal to 3 and a maximum height of 5. We're supposed to write the equation. So what's going on here is the biggest thing that I would tell you with most of these problems, and you've heard it in the first page, draw yourself a little picture, okay? We're not looking for perfection here, but we want to see what's going on. So I know I have a 0 at 1, and I know I have a 0 at 3, and there is a maximum height of 5. Things I know about a parabola. Zeros, by the way, are x-intercepts. All right, it's where you hit the x-axis or your function has a function value of 0. And the maximum height here, the word maximum tells me that this is a concave down parabola. All right, so I know that my vertex is going to hit the point, or it's going to hit the y value of 5. All right, and the other piece I know is parabolas are symmetric. So if you have a 0 at 1 and a 0 at 3, your vertex, there's a line of symmetry here that would go through the vertex, and it's halfway between your two zeros. Well, if your 0 is at 1 and 3, the halfway point would be 2. So this tells me we have some kind of a parabola that looks like that. All right, and there was the number 1 over there. There's the number 3 right there. So what do I know? Well, I know I have this vertex point, okay? That's my HK value. But I don't know what my focal distance is. I don't know, all right? So that's what we're going to have to find out. So I know this is a concave down parabola, so it's going to follow x minus h squared is equal to negative 4p y minus k. All right. And basically what I'm going to do is h and k is my vertex, so I can substitute those values in. And then I'm going to use one, it won't matter, but one of the two zeros. You can either use the point 1, 0, or you could use the point 3, 0. It's up to you. They'll give you the same answer eventually. I'm going to use 1, 0. All right, so I'm going to say that 1, 0 is my xy, and 2, 5 is my hk. And I'm going to plug that in because that will give me all the information I need except for the p-value. All right, so let's see. X is 1, h is 2. All right, so negative 4p times y is 0 minus k is 5. All right, 1 minus 2 would be negative 1. Negative 1 squared is 1 is equal to... Now, I'm going to do something a little bit weird here. I am actually not going to multiply negative 4 times negative 5. There's no reason to, and I will explain why in a second. I'm going to go ahead and divide both sides by negative 5. I promise there is a method to the madness, all right? Because now I'm going to tell you that negative 4p is equal to negative 1/5. Now, the reason I don't really care to figure out what p is, I could, right? I don't really care about it, though, is because, remember, in this equation, I need to replace negative 4p. Well, I now know what to replace negative 4p with. You absolutely could figure out what p is and then substitute into the equation and simplify. I'm just being lazy. So I'm not going to. All right. What I am going to do, though, is fill in this top equation, right? This standard form equation. I'm going to fill in h, k, and negative 4p with those values to write the standard form. So x minus 2 squared is equal to, now negative 4p here I know is equal to negative 1/5. So negative 1/5, and then y minus k was 5. All right. Now, unless the problem explicitly says to write the equation in general form, it is perfectly okay to write it in standard form and just let that be your answer, okay? All right, problem number 7, problem number 8 are just like the problems on the front of the worksheet, the first page of the worksheet. So I will put the answers up in the answer key, but I'm not going to talk through the video or talk through those problems in this video. I'm going to go ahead and slide on down to problem number 9. All right, find the equation of the parabola that contains the points A, B, opens upward, and whose focus is on AB. All right. So this is a little bit weird, right? But we've actually been given the end points of the lattice rectum. Now, how do I know it's the end points? Well, it contains these 2 points. These 2 points, let me go ahead and graph them. So 0, 1, and 4, 1. So that's 4 here. Okay. And it opens upward. All right, so it opens something like that. Okay, and whose focus is on AB. So if I were to draw a little line segment here, well, first of all, I recognize that's a horizontal line, so that helps. And basically what's happening is if I put the focus on there, well, that means that has to be the lattice rectum. All right, so this focus point is going to be halfway between the 2 endpoints. So that would be the point 2, 1, right? Halfway between those. Now what I want to figure out is how far is it from this focus point to this edge? Or actually what I could do is this whole distance is 4 units. So if the lattice rectum is 4 units long, that tells me my focus point, my focus distance is just 1. So I want to be 1 unit below this focus, which means I drew my graph completely wrong, but that's okay. All right, so if I pop this down 1 unit, my vertex should be right there. So I'm actually going to delete that graph there and redraw it a little bit better. Now that I know where my vertex is. There we go. All right, so what this tells me is my vertex is going to be at the point 1, 0, right? That's 1 unit below. Whoops, no, it's not 1, 0, it's 2, 0. Let's try that again. There we go. It's going to be at the point 2, 0. All right. Yeah, need to pay attention to what I'm doing here. And then... so I've got my vertex here. I've got my focal distance. So using that information, I can write the equation. This is opening up, so it's going to be x squared. It's going to be positive, and there's my y value. All right, so minus 2 here. Focal distance times 4. Nothing is going to attach to y because it's plus 0 or minus 0, so just let it be. So x minus 2 squared is equal to 4y. Again, unless this directions specifically say to write an equation in general form, please don't bother. Just write it in standard form and call it good enough. All right, so problem number 10 is just like what's on the front page. Problem number 11 is what we're going to bounce down to. And actually, problem number 11 is just like what we did in problem number 10. Literally just like what we did in problem number 10. The only difference is we have the graph opens downward. Okay, so let's go ahead and jump into that one, and hopefully I don't screw it up too badly if I try and do it quickly. All right, so let's see what we've got here. We've got 0, 1. We have 4, 1. All right, so that was going to be 4. That's 1. Okay, so we know this opens downward. All right, so something like that. Okay, and it did tell me the focus was on AB. It did. Okay, so I know that lattice rectum is 4 units long, which means my p-value is 1. I'm going to go halfway between there to get my focal point, which would be the point 2, 1. And I'm going to go up 1 unit, so that would be 2, 2 for my vertex. So if we use this vertex of 2, 2, this focal distance of 1, let's go ahead and make our equation. So x squared is equal to negative something, and then we've got y. So minus 2, and multiply my focal distance times 4. So let's see, x minus 2 squared is equal to negative 4, y minus 2. There we go. And no, I didn't have to write it twice. I just wanted to make sure I didn't have anything I could clean up in that problem. All right, last one on this page is going to be problem number 12. Okay, so find the equation of the parabola with focus at 0, 4, opening upwards, containing the point of 10, 4. All right, let's put this in a little graph here. Okay, so focus is 0, 4. It's going to be 4 units. It contains the point 10, 4. So this is 10. Okay, so this tells me a couple of things here. It tells me that I have half of the latus rectum. So remember, this focus and this point, they're horizontal to each other, so that means that's part of the latus rectum. If I reflected that to the right side, or to the left side, that would give me the other half of the graph. So my graph is doing something like that. Okay. So the total distance here would be 20 units across, right? It's 10 units to the left, 10 units to the right. So it's a total of 20 units. If I chop that up in 4s, that gives me a focal distance of 5. All right. So if this focus is at the point 0, 4, I want to go 5 units lower than that to get my vertex down here at 0, -1. That would be 4 units below that focal point. So now that I have my vertex and my focal distance, I can write an equation. So let's see, this is concave up, so it's going to be x squared is equal to positive something and then y. Let's see, x plus or minus 0 isn't going to matter. 20 is my total of the latus rectum, so go ahead and multiply that times 4. And then we've got y plus 1. So x squared is equal to 20, y plus 1. Again, nothing tells me I need to multiply this out, so I'm going to be lazy and not bother to. All right, so I will get the answers for the other ones that I skipped in this video onto the answer key. If you have any questions or concerns, as always, send me messages in Canvas or